In this video, we are looking at problems related to the power triangle. And you will need your trigonometric ratios, sine, cosine, and tangent, and also a scientific calculator or a trig table to estimate the values of sine, cosine, and tangent. I'm using the Casio FX260 that we use in the classroom, but you can use any scientific calculator or trig table to estimate these. And let's just review a little bit. I put a power triangle in here for you with each problem. It is a little bit blurry, but hopefully by this point you know this information. It is also in your textbook if you need that. But let's just review a little bit. This bottom segment, this bottom leg, is your true power. And I want to highlight that, not draw it in black. This is true power along the bottom. And let's try it again. True power. And then you have another leg of this right triangle. These are connected to the right angle itself. You have reactive power, which is indicated with VAR, VAR. And then the hypotenuse of this right triangle is your apparent power, which is indicated with VA. So I'll be using those variables and also the W for true power to do these problems. So again, we are working with the trig concepts of hypotenuse, here's the 90-degree angle. So hypotenuse is always across from the 90 degrees. If theta is located here, and we always start with theta, identify where theta is sitting. It could be in the other angle, but I think for most of these, the power triangle, I believe it's indicated here. So there's theta. Opposite theta is this side, var. So that is your opposite. And then touching theta, adjoining theta, is your adjacent side. So those trig ratios are still going to be important. As always, I'm going to make a note of SO, CA, TOA, because that will help me as I start working these problems. So just by way of review, those are the trig terms and relationships that you need to know. So let's take a look at number 1. This is a basic apparent power calculation. A circuit has a real power of 100 watts and a reactive power of 50. Calculate the apparent power. So we are looking for apparent. So let's do this process that we've learned. You know that you have 3 elements in a right triangle. You have hypotenuse, opposite, and adjacent. And I'm going to make a copy of this so you don't have to watch me write that every time. At least that's the plan. So let's see. All right, so it's really important that you identify these pieces correctly. So hypotenuse is indicated with the variable VA. Opposite is VAR. And adjacent is W. So those variables relate to these pieces. All right, some of them we will not need to use one of the trig ratios, but just in case, I'm going to go ahead and make, and I think I'm going to do one more thing before I copy. Hypotenuse is the red one here. Opposite for this particular triangle is shown in yellow. These are just my notes. This is not a standard by any means. And then your adjacent side, I'm using that purple color to mark adjacent. So just so you can relate those terms to this picture, because that is critical. You also need to know theta, which is your angle measurement That is the Greek letter theta, and that will be your angle number if you have one. Okay, so let me copy this. I started to do this off camera, but I thought this is a pretty good review. So let's see what we have here. A circuit has a real power, that's W, of 100 watts. So let's put 100 there for real power. That's the adjacent side. And a reactive power, that's VAR, of 50. Calculate the apparent power. So noticeably missing is theta. This is not a trig problem as far as the ratios. It's going to be a Pythagorean theorem problem. So in this particular triangle, we do not know hypotenuse. We don't know apparent. We know opposite. We know the reactive power is 50. And adjacent, we know to be 100. The real power is 100. So given the two legs of this triangle, I can use Pythagorean theorem to find the hypotenuse. And Pythagorean theorem is a squared plus b squared equals c squared. And then we just have to substitute some variables. I'm going to use 50 for a. It does not matter because we're building up this amount. And then that will give us c squared. So plugging in numbers for my variables, I'm setting up this formula. Be very careful with these because this is where a lot of mistakes are made. 50 to the second power, 5 times 5 is 25 with 2 zeros. You can use your calculator if you need to, that's fine. And then 100 to the second power, that would be 1 times 1, and you would have 4 zeros there. And then you add those two together to get 1250 with an extra 0, and that is c squared. But we want to know c, so we have to take the square root. I am using a calculator. So c would be plus or minus the square root of 12,500. And that is not an even number, so I'm hoping I can remember this. This is an approximation of 11.80. Sorry, 111.80. I want to round these to the tenths, and I'm just setting that rule. So the hypotenuse of this particular power triangle is approximately 111.8. And remember, hypotenuse is apparent power, so that would be in terms of VA. So this one did not rely on SOHCAHTOA. It relies on Pythagorean theorem. Okay, number 2, we are calculating power factor. A load draws 200 watts of real power and 250 VA of apparent power. What is the power factor? So in this particular situation, let's highlight just for practice, real power, and I can't remember, it's yellow on here, reactive power, and then the third component is apparent power, which is your hypotenuse. Your theta is right here, the 90 is right there. Okay, a load draws 200 watts of real power and 250 VA of apparent power. So this is hypotenuse. So I'm immediately thinking Pythagorean theorem. What is the power factor? So the question is not what is reactive power. That would be this dimension right here. If I wanted reactive power, then I would use Pythagorean theorem. But I want power factor. And that's actually another equation in your textbook where it's defined as power factor is PT over PA. And in our terms, that means W over VA. So true power, PT is true power, or power true, over PA, which is power apparent. And in our method notation, it is W over VA. But you could use either of those formulas. And so in this situation, W is 200, VA is 250, and we would want to simplify. So I'm going to take off a set of zeros. I'm left with 20 over 25, or 4/5. As a decimal, you're looking at 0.8. So your power factor for this problem is 0.8, or 8/10, or 4/5. Number 3, they want us to find reactive power. So they're looking for VAR. A system has an apparent power of 500 VA. That is hypotenuse. Oops, got the wrong color. We're looking for this one. Hypotenuse, I'm using red. Again, that is just an arbitrary color that I've chosen because I like it. So we have apparent power of 500. A real power of 400 W. So this is purple. And that value is 400 W. As soon as you know two legs or two sides of this triangle, you can find the third one with Pythagorean theorem. Calculate the reactive power. And again, this is VAR, so we want it to be this number that we're looking for. So I have a right angle. I know two of them. I'm missing the third one. This is Pythagorean theorem. It is not trigonometry because you do not know theta. Theta's here, but we don't know the value for theta. So this time I do know hypotenuse. I do not know one of the legs, but I know the other leg. And if you are familiar with the term Pythagorean triple, you can stop this problem right here. I will finish it for you. But I know that not all, you can't just pick three numbers at random and make a right triangle. There are certain triples that will work. And I know that 3, 4, 5 is one of them. So if I've got 400 and 500, I know that 300 has to be that A value. So let's finish this problem and see what we've got. So we don't know A, we'll leave it alone. 4 4s are 16, and then we have 2 zeros coming in from each of those terms. And then 5 5s are 25 with 2 zeros for each of the terms. So I need to minus the 16, the 160,000, cancel that. So I'm left with A squared equaling 25 minus 16 is 9 with 4 zeros. But we want to know the value of A. So A is plus or minus the square root of 90,000. And you guessed it, the square root of 90,000 is 300. So the apparent power, the reactive power, I'm looking at A, but A literally means VAR. The reactive power is 300. Okay. All right, I'm going to stop this video so these aren't so terribly long, and then we'll get the next page on the next video.